Dear Promise users and followers, in this video we will show you how to construct an OEE TEEP calculation model with Promise. This tutorial will not cover all options and possibility the Oee Constructor offers, but just the construction of a straightforward OEE calculation. These basics will enable you to play around with variations and more advanced options. You can always contact your local Promise supplier for questions on how to best utilize the features in your specific case. Let's get started. From the module bar, select the Admin module. Then choose the Oee Constructor. The Oee Constructor guide will pop up. If you not already have seen the video about the Oee Constructor guide, we urge you to view this video before continuing. You find the link to the Constructor Guide video above here. Follow the flow of the constructor to locate the Define OEE calculation block. You will see that the availability of a TCE is a prerequisite for the construction of an OEE calculation. For information on TCEs, we recommend you to watch the video linked above here. We also left links to the video about all OEE management in the comments below. So, click on the TCE block to see if there is at least a single TCE defined that we can use in the OEE calculation. Here we see that there are at least 3 TCE definitions available to use. Hence, the prerequisite is fulfilled. It is also possible to add external additional factors to your OEE. You'll find a link to this topic above and in the description below. In this case, we have a speed factor available, so we can use this as well in our OEE calculation. To define an OEE calculation, select the Define OEE calculation block in the constructor. If in your company someone already defined OEE calculations, they will be listed over here. In this tutorial, we find 2 existing calculations models. However, to construct a new one, click the plus icon below the list. Fill in a title for this calculation. Then select the production line from the Promise matrix that this new OEE applies to. In additional information about this calculation that describes the who, hows and whats of this calculation model, so anyone can understand the purpose of this model and why you build it. Once complete, continue to step 2, the calculation model. First, you have to add a TCE to the model to provide the model with a reference time frame. Click the plus icon next to Add TCE. A dialog with the list of predefined TCEs is presented. In this case, we will select the 3rd TCE with a reference frame of 24 hours. Now continue to step 3. Define the calculation model. The top section presents you with the data provided in the previous steps. Direct below that you find a green bar with the reference time domain according to your selected TCE. In this case, 24 hours. Below the green bar you'll find a row divided into 2 columns. Click somewhere on this row. A dialog pops up where you can add labels to the columns of this bar. The gray area represents the time domain considered as a loss compared to your reference frame. The white area is the time domain where potentially you can utilize your process given the availability of human resources. The division of the white area by the green area is your first OEE TEEP factor. Provide the name of this factor in the edit field left. Now fill in the labels you like to use for both the loss part and the productive part. In this example, we name the production part potential availability, the lost time due to collective labor agreements, social leave, holidays and CLA. You can add 3 lines per area. Next, we need to define the different paths or elements of the promise matrix that account for the time loss caused by collective labor agreements. Define all specific parts that belong to this production line, or with other terms, TCA, the time-consuming entity. In this case, everything booked within production line A under the topic HR social leave. There is also an option to add general path to a specific downtime component. These would be occurrences that cause downtime of this TCE, but find the root cause on a higher and or external level. For example, a power blackout of a general grid. For this tutorial, we will not use these options. Once you defined all paths leading to CLA-related losses, click Save to complete this level. As you can see, your definition of the first OEE TEP level is presented in the model. Below the first 2 rows, a next row is added to be defined by you. Now click on that row. Now add the labels for the 3 elements of the model. The time loss domain is labeled planned downtime. The residue of it is called gross planned availability. The accompanying OEE factor is your planning factor. Assign all promise matrix parts that account for planned downtime, and now save this row also to the model. Continue to define the next level of your OEE calculation model. This factor could include all downtime caused by maintenance. Hence, we name the loss component maintenance, and the residual time domain is your operational availability. The factor we label maintenance factor. Again, assign all matrix paths that account for downtime due to maintenance to this topic, and also save this OEE level. Now define the final level for this model. This will be downtime due to all other root causes except the already defined ones. We label the downtime domain simply downtime and the productive time domain uptime. And let's call the factor productivity factor. Finally, add all the matrix parts still available and accounting for downtime. And then save this OEE level. We now constructed a time domain TEP model calculation with all definitions for CLA factors, planning factors, maintenance factors, productivity factors, and their accompanying time definitions. In addition to these factors, you can now define additional factors. Many companies calculate an additional operational OEE as the division of the uptime by the gross planned availability. To define such a factor, go to the section Additional Calculation Factors. There, click on the plus icon, and in this dialog, name your factor. Then select an OEE item by clicking the numerator term and select from your model the term that becomes the numerator. Click the denominator and select an OEE item that should be your denominator for this factor. Click Save to add this factor to your model. You can add as many factors as you like. Finally, you can add external factors like your production speed. This factor can be supplied by promise to a historian like Sense. But every historian, when properly configured, should be able to provide you with a normalized production speed factor. To add an external vector, see link above about external factors, unfold the top external factor section and click the plus icon to add an external factor. From the dialog, select the external factors available in the list. For this tutorial, we'll leave the option to add general extra failures out of scope. It would only complicate this tutorial. The final step for our OEE calculation model is to add KPIs. Therefore, continue to watch step 4 by clicking the Define KPIs button. This opens the Define KPI screen. The second section of this screen contains a suggested KPI by Promise. You can modify that KPI by clicking the green pencil icon. To add a new KPI for the report, click the plus icon below the list of already defined KPIs. In the dialog, fill in the name of the new KPI and click the plus icon to add its first factor. From the following dialog, select a factor to add to the KPI. And repeat these steps for all the factors for this KPI. Once you have added all the factors, click Save to add this KPI to your list of KPIs. If you have completed your list of KPIs, finalize your OEE calculation model by clicking the Save OEE Model button. Promise will now return to the general OEE Constructor guide, and at this stage you can start to construct OEE reports based on your calculation models. Constructing reports is covered in a separate video. That will be all for this video. Don't forget to subscribe to our continuous improvement channel, and I'll see you in the next video.